What if I told you that 2,400 years ago, in ancient Greece, a man predicted the atom without ever seeing one? No microscope, no laboratory, no equations, just pure thought. His name was Democritus, a philosopher, a wanderer, a laugher of absurdity. He didn't believe in the gods. He didn't believe in divine design. He believed in something no one could see. All things are made of invisible particles, indivisible, indestructible, always in motion. Today, physicists use billion-dollar particle colliders to probe the structure of matter. They speak of quarks, leptons, bosons. But before CERN, before Einstein, before Newton, there was him. So how did an ancient Greek philosopher get so close to the very truth of the universe? Was he a genius ahead of his time? Or was the universe always whispering its secrets to those willing to listen? Democritus was born around 460 BCE in Abdera, a coastal city in Thrace. But unlike the revered Plato or divine-seeking Pythagoras, Democritus was a materialist and a skeptic. He didn't seek meaning in myths. He didn't bow to Olympian deities. He laughed at them. He traveled far, to Babylon, Egypt, India, studied under magi and mystics, yet remained unmoved by superstition. He asked one question: what is everything made of? And the answer he found was breathtakingly simple: only atoms and the void. Democritus proposed that all matter is composed of atoms, from the Greek word atomos, meaning uncuttable. These atoms, he claimed, were eternal, indivisible, infinitely varied in shape and size, always moving in the void, colliding, rebounding, combining, creating everything from rocks to rivers, thoughts to stars. By convention, there is color. By convention, sweetness. By convention, bitterness. But in reality, only atoms and void. He saw the soul as atoms. He saw thought as atomic motion. He even imagined that taste, sound, and touch were just subjective interpretations of atomic arrangements. No rituals, no afterlife, no divine purpose, just motion and matter, forever cycling. But Democritus paid a price. The world wasn't ready for such cold clarity. Plato reportedly despised him. Aristotle ignored him. Later, Christian theologians banned him. Atomism was too dangerous. It denied the soul. It challenged divine creation. It left no room for heaven. For over a millennium, his works were buried, burned, or lost. Only fragments survived. His legacy lived on, in whispers. Until one day, centuries later, scientists began asking the same questions. What is matter made of? Can the universe be reduced to fundamentals? Suddenly, Democritus returned, not as a prophet, but as a precursor. In the early 1800s, John Dalton proposed a new atomic theory, eerily similar to Democritus. Then came J.J. Thomson and the electron. Rutherford discovered the nucleus. Bohr gave us quantum orbits. Heisenberg shattered certainty. Feynman mapped quantum electrodynamics. Today, we have the Standard Model, the blueprint of reality. It describes 12 fundamental particles, 4 forces, the Higgs boson, which gives mass to matter, and yet, at its core, it is still atomism, upgraded, expanded, and quantified. Particles, void, motion, interaction. We smashed the atom, split it, looked inside, and what did we find? Smaller atoms, smaller voids, more questions. How did a man with no microscope conceive of particles? Could pure reason uncover truths that science would take millennia to confirm? Or was it all just poetic coincidence? Democritus believed in determinism, the idea that everything, even thought, was governed by natural laws. He rejected free will, divine intervention, cosmic justice. In doing so, He laid the groundwork for a materialist worldview, one that science still builds upon. He didn't prove atoms existed, but he imagined them, and that might be more profound, because he didn't just ask what the world is made of. He asked, what if there's no magic? What if reality is enough? That question still haunts physicists today. But here's the twist. Modern particle physics is not identical to Democritus's atomism. Atoms are not indivisible. They're not eternal. Particles pop in and out of existence. Quantum fields vibrate. Matter may be information. So, did science confirm Democritus, or did it shatter his vision? In ancient Greece, atoms were thought to be indivisible, solid, eternal, and unchangeable. They were not made of smaller parts, and they never appeared or disappeared. They just rearranged. In contrast, modern atoms are mostly empty space. They're made of protons, neutrons, and electrons, and even those are made of quarks and gluons. Worse yet, particles can transform. Electrons can appear and vanish in quantum fields. Particles aren't always stable. They don't even have fixed locations. They exist in probability waves. So no, Democritus's atoms were not the same as today's atoms. But the core idea that everything reduces to small parts still holds. Yet today, we don't even think in particles anymore. We think in fields. According to the Standard Model, every particle is actually a quantum excitation in a field. An electron is a ripple in the electron field. A photon is a ripple in the electromagnetic field. The Higgs boson is a ripple in the Higgs field. So instead of billiard balls in space, the universe is more like a fluid ocean of vibrating fields, where particles are merely disturbances in the calm. Democritus imagined tiny objects. Physics sees dynamic fields. He saw permanence. Physics sees flux. Democritus believed in a deterministic world. If you knew where atoms were and how they moved, you could predict everything. Modern physics? Not so much. Thanks to Heisenberg's uncertainty principle, we can't know both the position and velocity of a particle. Thanks to quantum entanglement, particles can affect each other instantaneously across galaxies. And thanks to wave-particle duality, even the tiniest particle acts like a probability cloud. This would have been unthinkable for Democritus. His atoms were reliable, concrete. Ours, not so much. Here's the biggest blow to ancient atomism. Democritus believed atoms had mass inherently, but modern physics says mass comes from interaction with the Higgs field. Without the Higgs, all fundamental particles would move at light speed. Mass doesn't exist until particles drag through that field. This flips Democritus's idea on its head. Mass isn't a fundamental trait. It's a byproduct of deeper interactions. So, was he wrong? Yes and no. Democritus didn't predict quarks or the Higgs boson. He didn't imagine probabilities or quantum foam. But he proposed that everything could be reduced to fundamental units, and that nature followed laws, not divine whims. That was revolutionary. He planted a seed that Newton, Einstein, and Feynman would later nurture. Even if his model was flawed, his framework, a logical naturalistic universe, became science's foundation. Democritus thought the truth of reality could be reasoned without experiment. Today, we have experiments, but no final answers. We ask the same questions. What is real? What is fundamental? Is there anything beneath the fields? Is the universe built from math, from code, from nothing? In the end, Democritus didn't just predict atoms. He predicted our curiosity. He taught us that behind the chaos, there might be structure. And even if we never reach the bottom, the search itself is the point. So where does that leave us? We've split the atom, dissected its core, reduced it to quarks, strings, and fields, but the more we learn, the less solid the universe becomes. Particles? Not real. Mass? Emergent. Reality? Maybe just math. Or worse, information. Some physicists now believe the universe is not made of things, but of relationships. Not atoms, but interactions. Not substance, but structure. Sound familiar? By convention, there is color, but in reality, only atoms and the void. Now replace atoms with fields, or qubits, or information nodes. Suddenly, Democritus is back, not as a scientist, but as a philosopher who asked the most dangerous question. What if nothing is sacred, not even reality itself? Physics today is facing a crisis. We have the Standard Model, which works beautifully, and general relativity, which works beautifully, but they contradict each other. We can't explain dark matter, dark energy, or consciousness. We can't unify quantum physics and gravity. Equations pile up, experiments stall, certainty vanishes. So where do we turn? Back to philosophy, back to the very roots of science, where questions were existential, not just technical, where we asked, is the universe infinite? Can we ever know reality? Are we part of the equation, or just observers? This isn't nostalgia, it's necessity, because when data runs dry, all we're left with is thought. Democritus didn't just anticipate atoms, he didn't just whisper to the future. He reminded us that thinking deeply, radically, dangerously is the beginning of all discovery. That science, at its core, is a philosophical rebellion against easy answers. He dared to imagine a world without magic, and found meaning in motion and matter. Not because he was right, but because he was willing to be profoundly wrong, in a way that shaped centuries. So, did Democritus discover the universe first? No, but he discovered the courage to question it, and in doing so, he gave birth to the very spirit of science.